These are something which we discussed in last lecture. So let's just get through it. That's the book we're going to follow. I will following it Moment Elementary Linear Algebra by Howard Anton. It's the 10th edition. We do have a 11th edition as well. I shared both books in Google Classroom. You can follow either one. The basic concepts are same. There might be difference in the question, so don't worry. I presume these are things we discussed in last lecture, right? So we're going to start from here. The first chapter of that book is all about introduction to system of equations, and obviously about at the end there's an application of system of equations. So these are the main topics we're going to cover in this chapter. Okay, introduction to a system of linear equations, Gauss elimination. We will be discussing that. I hope you know some of these things. I might be explaining something differently. Matrices, matrix operations. We'll be talking about finding inverses by elementary row methods and something. And then some more things on linear systems, invertible matrices. We'll be talking about diagonal, triangular, and symmetric matrices. Right, so we're talking about all these things. Okay, why do we study system of equations, linear system of equations? They are basically usable in various physical problems and a real life problem. I'm giving a simple example here. I hope everybody know how do we balance a chemical reaction. I presume everybody knows that. We might have done that by hit and trial. You multiply one number, another number, and then you count the number of atoms on both sides, and you balance the chemical reaction. We can do the same thing by using system of equations as well. There are many applications. We'll be talking about them later on. Application of system of equations. But at this moment, I'm giving a simple example. I hope everybody knows that reaction, chemical reaction of hydrogen and oxygen. That is H2 plus O2. That is equal to, can I presume everybody see my screen?
Yes, sir.
Okay. So that gives you H2O. I presume everybody knows that. Even though you have not studied chemistry, you should have studied that in maybe in matrix. You know H2 plus O2, that is H2O. We want to balance this chemical reaction by multiplying various numbers here. It's a very simple one. Everybody knows how to balance this one. But what do? We are using system of equations to balance this reaction. So let me take X here, Y here, and Z here. Okay. So, okay. So first we generate equations from it. We count atoms of hydrogen on both sides first. So you see we have X here. There are X side atoms, and from here we have on the right side we are having 2Z. There are two X atoms on left side and two Z atoms on right side, which give you a simple equation X is equal to Z. That's one equation. Or you may write X minus Z is equal to 0. It's a homogeneous equation. We talk about atoms of oxygen as well on both sides. So we are having 2 times Y, and on the right side we have only one oxygen, so that is Z. This equation may be written as Z is equal to 2Y, or Z minus 2Y is equal to 0. We are discussing in a while if we have two equations, you see we are having two equations in this case, but there are three variables x, y, and z. Right? There are three variables and two equations. So you might have learned in FSC that there would be one free variable. The difference between number of equations and number of parameters, sorry, number of variables, that is usually the number of free variables. What do you mean by free variable? Free variable means whose values can be determined by the user. You can put the value by yourself. That's what we call a free variable. So now we are having two equations, but there are three variables. Okay, two equations while three variables. So there would be the difference between them. 3 minus 1 is 1. So there will be one free variable, and that could be anyone. So we assume that y is a free variable, and you can give any value to y here. Let's suppose y is equal to 1. If y is 1, what about z? Z will be 2, because you see z is equal to 2y. So z will be 2. What about x? X is also equal to z, so x is equal to 2 as well. So if you put these values here, replacing x with 2, y with 1, and z with 2, this chemical reaction will be balanced. 2H2 plus O2 equals 2 times H2O. What happens? By using system of equations, we balance this chemical reaction. It's obviously balanced. You can have different numbers as well. By free variable, we mean you can take any value. You may take y is 2. So if y is 2, z will be 4, x will be also 4, and by putting these values here, it will also be balanced chemical reaction. But usually we choose the smallest number, smallest integer. We don't consider fraction. You can, even though if you have a system of equations, you can have 1 by 2 as well. But we don't use 1 by 2. We don't say that half is this one is this one is this one. So that's the motivation that why do we study system of equations. We do use system of equations in networks as well. We'll be discussing that later on. We use in economics as well. We use linear system of equations and matrices or linear algebra in cryptography as well, etc. We'll be discussing some of them later on. Okay, I hope everybody knows linear equation. So linear equation is an equation with power equals 1. You see, this is a linear equation in two variables, and that basically represent a line. Equation of degree 1 in two variables, keeping in mind that is representing what? That is representing a line, straight line. Whereas if you have three variables, x, y, and z, so a line with, an equation with three variables, and if it is linear, you see linear means again power should be 1, power is 1. This is linear with three variables. It represents planes in space, because when we have three variables, it means we are in space. In that case, a linear equation representing a plane. You see, a plane could be anything. It is a plane. Okay, the computer screen is a plane, and so on. We may have a linear equation in more than one variables. So say a1x1, that's one variable, power is 1, a2x2, another variable, up to an xn, this is the nth variable. So there are n variables in this case, where a1, a2 up to an, they are the coefficients, where b is the right hand side, which usually called a source term or input in that case. Okay, and a1x1, a2x2 up to anxn. If a1, a2 up to an, they are known, and you want to find x1, x2 up to xn. So yeah, we are using that in many applications. Sometimes these values are known, x1, x2 up to xn, and we need to find the values of a1, a2 up to an, which usually happen in artificial intelligence or convolution networks and stuff like that. That usually happen there, that you know these values, that's the input data, and you are finding the weights w1, w2, and w3, which still we use for a system of equations for it. So equation of degree 1 in two variables that represent a straight line in plane, whereas it depends upon the nature of the geometry. Sometimes, even though if you know that you are in 3 dimension, right? You are in 3 dimension and you have only one variable, that is something like ax is equal to b. Okay, if you are in 1 dimension, so that's simply a point. If you are in 1 dimension, right? If you know that I'm in 1 dimension, it will be simply a point. Whereas if you are in 2 dimension, it will represent straight line, even though you are having one variable, but that is a straight line if you are in 2 dimension. Okay, and the same equation represent a plane if you know that you are in 3 dimension. Okay, if you are in 3 dimension, in that case this equation will be representing what? It will be representing a plane. If you come to two variables, ax plus b, y is equal to c, this line has no meaning. Okay, it's just so ax plus by is equal to c. Again, we cannot have ax plus by is equal to c in 1 dimension. It could be either 2 dimension or 3 dimension. So in 2 dimension, it represents a straight line, but if you are in 3 dimension, it represents a plane. And obviously, if you have ax plus by plus cz is equal to d, it cannot happen in 1 dimension, it cannot happen in 2 dimension, it will be in 3 dimension, and in 3 dimension it is representing a plane. So if you know about the dimension, then accordingly all those things means differently in different dimension. I hope you know these things because you might have studied calculus. Oh, do you? Okay, these equation could be non-homogeneous and they could be homogeneous as well. You see, as I said, we are having b here. So if b is non-zero, if b is non-zero, because b could be anything, this equation is known as non-homogeneous equation. But if b is 0, that means it is a homogeneous. So non-homogeneous basically means there is some inflow in the system. There is some inflow in the system. For example, you see a bit earlier when we were finding coefficients for balancing that chemical reaction, we had homogeneous equation because there was no inflow in it. That was the equilibrium problem, right? So we had a homogeneous equation. But if you have a flow in the system as well, so there will be a non-homogeneous equation. You'll be having something on the right side as well. Okay, and if there is no, then it will be homogeneous. So if the right hand side is zero, it doesn't mean that right hand side is zero. You see, the constant term is zero, because somebody could write this equation is let's suppose, sorry, if I write that as ax plus by plus c is equal to 0. If somebody write this equation in this form, now you see the right hand side is 0, but it's still non-homogeneous because we are having a constant term. If c is 0, it will be homogeneous, and if c is non-zero, it will be non-homogeneous. It doesn't matter, or you cannot define it by saying that right hand side is 0 or it is non-zero. It doesn't matter, right? It depends upon the constant term. If constant term is there, it will be homogeneous. If constant term is not there, it will be non-homogeneous. For example, we say 2x plus 3y minus 4 is equal to 0. So it is a non-homogeneous because we are having constant term here, 4. And if you have 2x plus 3y is equal to 0, this is homogeneous equation now because there is no constant term involved in it. So by only considering that either right hand side is 0 or non-zero, you cannot decide about whether a system is homogeneous or it is non-homogeneous. Any question? That's homogeneous equation in n variables. Okay, x1, x2 up to xn. As I said, we may have homogeneous equation in one variable. We may have homogeneous equation in two variables up to n variables. Then we talk about system of equations. And it will be obviously linear equation. All the time we'll be talking about linear equation because we are in linear algebra. Everything will be linear. Usually in calculus, we discuss what curves, bending, curvatures, etc. We talk about that. Whereas in linear algebra, we talk about flatness. Everything should be flat. Right. You see, in this equation, if you count the equations, there are m equations. You see, 1, 2, up to m. And we are having n variables, x1, x2, up to xn. So there are m equations and n variables. Okay. Now, keeping in mind, if you convert this into a matrix form, which is coming a bit later, but I want to explain that here. In a matrix form, and write in this form, we say Ax is equal to B, where A is representing the coefficient matrix. So in coefficient matrix, if matrix a system is given in matrix form, okay, it might be A11, A12, and so on, up to A1n. Whereas this is going up to AM1, AM2, up to AMN. So this is a matrix of order m cross n, means there are m rows and n columns. So keeping in mind, in any matrix, the number of columns is determining the number of variables. Number of columns are basically telling you about what? About number of variables, right? Whereas the number of rows, they are determining number of equations. If you have 3 columns and 3 rows, it means in the system there will be 3 equations and 3 unknowns, 3 variables, right? And that happens in coefficient matrix. If we are in coefficient matrix, in case of augmented matrix, I hope you know what is augmented matrix. When you augment a last, there's another column in it which is b1, b2, b3, which is b1 up to bm. It becomes augmented matrix, which is denoted by A sub B, or we may write in this form as well, A, and then we draw a line here, and then we write B here. This is augmented matrix. So in determining the number of rows and number of equations and number of variables, we don't consider this last column in case of augmented matrix. You can compute, you can count, you can find the number of equations and number of variables from the coefficient matrix. We don't consider that augmented matrix. We do consider augmented matrix, but we will not consider the last column. If there are 10 columns, including the last one, so the number of variables will be 9 in augmented matrix. While in coefficient matrix, if there are 10 columns, there will be 10 variables. And if there are 5 rows, so there will be 5 equations in it. So keeping this thing in mind, because we'll be using that again and again later on as well, that how many variables do we have and how many equations do we have, and whether number of equations are same and one number of variables are number of equations and number of variables are same or not. We'll be talking about this again and again and again, so we should know that. So that's a system of equation. Again, we are considering two types of systems. One is non-homogeneous system, whereas the other one is homogeneous system. If all of these are 0, this is 0, this is 0, everything on the right side, the value of b are 0, the system will be homogeneous. Whereas if they are not 0, one of them is not 0. Suppose if this is 1 and the rest are 0, doesn't matter, it could be anything. So if at least one of them is non-zero, it becomes then non-homogeneous system of equations. Even though one of bi is non-zero. If all bi's are 0, in that case it will be homogeneous. If at least one bi is non-zero, it will be non-homogeneous. I take attendance before I proceed further. I'm having only 11 students in the class.
सर आज 7-8 स्टूडेंट्स का कामयाब प्रोग्राम नौजवान प्रोग्राम जो नहीं है उसका इंटरव्यू था तो वहाँ गए हुए हैं.
अच्छा, okay. You should check your name right here in the list, and then don't ask me later on that my name is there or my name is not there. Okay, next we talk about solution of a system of equation. And first we discuss that geometrically. What do we mean by solution of system of equation? So if you talk about system of equation in two variables, as I said, equation in two variables is basically representing what? That's a straight line. If you have two straight lines, a1x plus b1y is equal to c1, a2x plus b2y is equal to c2, there are three possibilities that these lines may intersect at one point, they coincide with each other, or they have no common point. If the lines are parallel, if a1 is equal to a2 and b1 is equal to b2, or a1 by b1 is equal to a2 by b2, so these equations or these lines will be parallel. Okay, and then depending upon the value of c1 and c2. Okay, so I'm giving you a few examples where we have no solution, where we have one solution, or we have many solutions. If the lines coincides, they are the same lines. In that case, there will be infinitely many solutions. Okay. So I'm considering two examples, simple examples. So let's suppose we have one system as x plus y equals 1 or maybe 2, and x minus y equals 0. Okay. So if you solve this system of equation, they can be solved easily and we could find the solution. And I'm going for Gauss elimination method. So its augmented matrix will be 1, the coefficient, and then we take the right side of it. It is 1, it is minus 1, it is 0. We convert that into Echelon form. I hope everybody knows what is Echelon form. That is 1, that is 1, that is 2. And if you go for the operation row number 1, subtracting row number 1 from row number 2, you could write R2 minus R1. We get 1 minus 1, that is 0. This is minus 1 is minus 2. And we have 0 minus 2 is minus 2 as well. And then from the last row, we can say, if you convert them back into equations, we get 2y is equal to minus 2, which gives y is equal to 1. And putting y is equal to 1 in first equation, this one, we get x equal to 1 as well. We see in this case, we are having unique solution. Okay. And there will be only one point of intersection, and that's the case for this one. Geometrically, it means like that. If you have one line, we have another line, and there is a one point of intersection of that, and that intersection is at 1, 1. Okay, next one. If you consider the same system, x minus y, x plus y is equal to 2, whereas x plus y is equal to 3. So again, if we consider corresponding augmented matrix, and we convert that into Echelon form by same operation, 1, 1, 2, we get 0, 0, and minus 1. We applied the same operation, right? Row number 2 minus row number 1. So from here, the last equation is giving you what? 0 is equal to minus 1, which is not possible, which is impossible. So therefore, the system has no solution, and that's the case in this one. We may have x plus y is equal to 2, whereas x my 2x plus 2y is equal to 4. And then the augmented matrix will be 1, 1, and 2. This is 2, 2, and 4. Applying row operations, again we have 1, 1, and 2. If you go for the row operation, that row number 2 minus 2 times row number 1, 2 minus 2 is 0, 2 minus 2 is 0, 4 minus 4 is 0. If you convert, the last equation is 0, you see. We don't have that, we don't consider that. We come to the first row, and that gives you x plus y is equal to 2. Now we are having, as I said earlier, we are having one equation with two variables, x and y. So there will be again one free variable. Mean to say you can have any value for either y or x. You can put that yourself. So if you take y is equal to 0, x will be 2. If you take y is equal to 1, x will be 1. If you take y is equal to 2, x will be 0. If you take y is equal to minus 1, x will be 3. So you can see in this case we are having infinitely many solutions. Now, in case of two variables and two equations, when would we have many solutions, unique solution, and no solution from the echelon form of augmented matrix? You see, the augmented matrix for unique solution within echelon form is what? This quantity and this quantity, they are non-zero. We don't care about this one, we only care about this one. If this quantity is non-zero, the system will be having unique solution. Whereas in case of no solution, if this is 0, this position is 0, whereas this is non-zero, right? Then we say the system has no solution. And if both are 0, this one is 0 and this one is 0, in that case, we are having many solutions. Okay, if we talk about three equations with three variables, as I said, in equation, linear equation in three variables represent a plane. Okay, so these are situations where we have usually no solution, many solutions, and unique solution. If you are having planes like that, if they are parallel to each other, but they are apart, so there will be no solution. If two of them are parallel and the third one is not parallel, again no solution. If one is in this direction and they are forming a sort of triangle, again there will be no solution. There is possibility that two planes are parallel and two planes are same and the third one is parallel to it, again there will be no solution, right? And if the three planes intersect in the following way, if they intersect at one point, if this is the one plane, this is another plane, and this one is another plane, so they basically intersect a common intersection point, that is this one. So in this case, the system will be having a unique solution, right? So if you look into your room where you are sitting, and then observe the wall on your right side, that is a one plane. A wall in your front, that is another plane, and the ground That's another plane. So they in fact intersect in one point, and that is the corner of that room at this position. देख सकते हैं आप? अगर आप रूम के अंदर बैठे हैं तो आपकी जो राइट साइड पे एक प्लेन है, वॉल है, इसको हम प्लेन कंसिडर करते हैं। आपकी फ्रंट पे जो प्लेन है उसको भी हम, जो वॉल है उसको भी एक प्लेन कंसिडर करते हैं। जिस पे बैठे हैं, जिसको हम फर्श कहते हैं, वो भी एक प्लेन है। और ये तीनों जो प्लेन्स हैं, दे इंटरसेक्ट इन वन पॉइंट, एंड दैट पॉइंट इज बेसिकली द कॉर्नर ऑफ द रूम। Is it clear? Okay.
Yes.
And in case if you have three planes, and like this one, this is one plane, there's another plane, and there's another plane, so they have an intersection in a line. This complete line is the intersection of it. And we are having infinite points on this line. So in this case, we are having many solutions. If all the three planes are same, they lies on each other, so many solutions. If two of them are lying on the same position and third one is somewhere else, in that case, we are also having infinitely many solutions. Okay, another question is, how would we know from echelon form of a matrix in case of three variables that we have no solution, we have many solution, and we have unique solution? Keeping in mind, whenever we have a free variable involved in the solution, there will be infinitely many solutions. Okay, so you see, if I just consider a system of equations, let's suppose I have something here, something here, something here, and then we have a right hand side here, which could be anything. That is 0, something here, something here, something here. This is 0, this is 0, we have something here, something here. If this is the, if you consider 3 cross 3 system, keeping in mind, right? Now, if this quantity is non-zero, I put cross here. Wherever I put cross, I would mean non-zero. I put 0, that means 0. If I put dash, it means it could be anything. It may or may not be 0. It may be 0, it may be non-zero. Right? So if this quantity is non-zero, in that case, you may observe the number of equations 1, 2, 3, 1, 2, 3, they are same, so you'll be having unique solution. If this quantity is non-zero, and you can have anything here, it could be 0, it could be non-zero, you'll be having unique solution. Whereas in case of a matrix in this form, anything, 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 and then the right side, you may have 0 here, you have anything, 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 you have 0 here, you have 0 here, you have 0 here, while you have non-zero here. So what happens? The last equation is giving you something impossible. You say 0 is equal to a non-zero quantity. So in this case, we'll be having no solution. Right? And if we have augmented matrix of a system like this one, zero here, something, something, zero, 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 and this quantity is also zero. Now what do? We go to the second row then, because the last row is gone. Okay, it means there is no third equation. We are having three variables while we are having two equations, because this equation is gone. 0 is equal to 0, so that's gone. Now we look into this one. If at least one of these two, if one of these two is non-zero, right? This one is non-zero or this one is non-zero, then the system will be having many solutions. If one of these is a non-zero, there will be many solutions. Both could be non-zero as well. If this is 0 and this is non-zero, many solution. This is non-zero, this is 0, many solution. Both are non-zero, many solution. But if both are 0 and this one is non-zero, if that's the case, then anything, anything, and then we go to anything. We are having 0 here, we are having 0 here, we are having 0 here, but here no 0, whereas the last row is already 0. In that case, again we say no solution. But if this one is also 0, and then we have 0, 0, and 0, 0. Okay. And then obviously, if you go back to the first equation, if there are some equations, at least one of these will be non-zero, and then we have many solutions. Okay. Sometimes at the beginning, we have more equations than variables. For example, if you are having something like that, something, 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 and then we have a right side here, something. It is a system, okay? It is not converted into Echelon form yet. So you see, we are having three variables and we are having 5 equations. So we convert that into Echelon form first. If you go for Echelon form, the Echelon form may look like something, something. Keeping in mind, we are having 3 variables now and there are 5 equations because number of rows are 5, whereas number of columns are 3. We don't consider this column, it's the right hand side. There are 3 columns, 3 variables and 5 rows, so it means there are 5 equations in it. If you convert that into Echelon form, it may take the following form. this one, it would be 0. Again, it is something, something, and something. These two must be 0, 0, 0. This something here, sorry. It may or may not be 0. Okay. This will be 0, this will be 0, this must be 0. Now, if this quantity is non-zero, the same thing for the last row as well. 0, 0, 0. Must be something like that to convert that to Echelon form. Okay. And we need to make this one 0 as well. Now, if this one is 0, or if this one is non-zero, this quantity, if this quantity is non-zero, in that case, the system will be having no solution. This should be 0 because if you convert that into Echelon form, it must be 0, right? The last row, that will be completely 0. But if this is 0 and this is non-zero, in that case, the system will be having no solution. Whereas if this is 0, if that is the case, something, 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 right? And then we have 0, something, something, 0, 0, and then something here, something, and the last two rows are 0. If this is 0 as well, this is already 0. Now, if this quantity is non-zero, if this is non-zero, in that case, you will be having unique solution. Even though the last two rows are 0, in previous case, we said if this is 0, there might be many solutions. If this is 0, this is 0, there will be many solutions. There is a case when there is no solution, but whenever you have a last row 0, when at the beginning number of equations and number of variables are same. If at the beginning number of variables and number of equations are same, so we are having this case. If the last row is 0 and one of these is non-zero, we are having either many solution or we are having no solution. Okay, but in case when we have more equations whereas less variables, in that case, even though if the last two rows are 0, this one and this one, we can still have unique solution, and that happens when this quantity is non-zero. And if this is 0 and this is non-zero, so we are having no solution. If this is 0, this is 0, the rest is then again same. If these two are 0, this one is 0, this one is 0, and one of these two is non-zero, so there will be many solutions. And again, if these two are 0 and this one is non-zero, this one is non-zero, then no solution. And if these two are 0 and this one is also 0, then we are having many solutions. This thing is very important, and you need to learn it because I'm going to use this again and again. And you should have practice to convert a matrix, how to convert a matrix into Echelon form. Any question? You may take screenshot of this slide because this will not available later on. It will be the recording, but I'll be sharing this lecture in the Google Classroom, so these explanations are basically not available. आगे जाऊं, मैं इसको रिमूव करूं?
ये सर ले लिया स्क्रीनशॉट।
Yes, sir.
Okay. If you have any question in this slide, you can ask. Any concern, any query? Okay. So that was geometrically, and as I said earlier, that is in case of augmented matrix to check whether a system has many solution, unique solution, or no solution. So we call a system consistent if it has some solution, at least one solution. It might be one solution or it might be many solutions. We don't have any system which has two solutions unless you put some constraint on it. You put some values, or to put in values of x in an interval, right? Otherwise, generally we don't have a system of equations which has two solutions or three solutions. A system may have no solution, a system may have one solution, or then infinitely many solutions. So a system with one solution or many solution is called consistent, and a system with no solution is called inconsistent. This is an example of a system of equation which has one solution, unique solution, and I had already given another example, so you can get through it quickly yourself. How can you solve this system? You may add them together, or you may subtract two times the first equation from the second, whatever. You can convert that into augmented matrix, and then you convert into echelon form. You get this value. So x in this case, y in case 4 by 3, whereas x is 7 by 3. So that is a unique solution. In this case, the system has many solution, no solution, sorry. Again, if you convert that into echelon form, that is giving you 0 is equal to -6. So this system has no solution, as I gave example earlier. If this is a system, in this case we are having 0 is equal to 0, which is obviously an open equation. So we are having only one equation. You can leave this equation because 0 is equal to 0 is always true. We have 4x minus 2y is equal to 1. Now we have one equation with two variables, so the system will be having a free variable, one free variable. The difference between number of equations and number of variables. Number of variables minus number of equations give you number of free variables. And if a solution has a free variable, it will have many solutions. In this case, we are having one equation and two variables. So there is one free variable. Okay, and therefore the system will be having many solutions. That's the case of three variables. If we consider augmented matrix, let me go for that. So in this case, augmented matrix will be 1, -1, 2, and the right side is 5. 2, -2, 4, and 10. 3, -3, 6, and then 15. And that's the augmented matrix. Okay. So if you convert that into echelon form, what do we do? This will be a row, this is row equivalent to number 2 minus 2 times row number 1, that may give you 1 minus 1, 2, and then 5. So this will give you 2 minus 2 is 0, minus 2 plus 2, 0. This is 0. 10 minus 10 is 0. And if you apply this operation, row number 3 minus 3 times row number 1, it also gives you 0, 0, 0, and this is 0 as well. So see that this one is 0, this is completely 0. So by using that concept I explained earlier, it will have many solutions. This system will be having many solutions. Okay, and how could we find those solutions? If you convert this again into equations, we get this equation. You see, now we are having one equation and three variables. There are three variables and we are having one equation. So the difference of these two, 3 minus 1 is equal to 2. So there will be two free variables. There will be two free variables. It means among these three, x, y, and z, you can give any value to two variables of them. So we generally introduce a parameter. We say y is equal to r, z is equal to t, where r and t could be any real number. You can take anything. You can say y is r and z is t, or maybe y is r and z is s, and in that case x will become what? X is equal to y is taken as r minus 2s plus 5. 2t, sorry, plus 5. So that's why we have this solution. X is, they have taken z is equal to s, I have taken t. So x is 5 plus r minus 2t. Okay, y is r and z is taken as t. So for selecting any value of r and t, you'll be getting solution of this system of equation. You may take r equal to 0, s equal to 1. You may take r equal to 0, s equal to 0 as well, and then find corresponding value of x. That will give you solution. Any value of r and t will give you solution of this system of equation. And obviously we are having many infinite values of r and t, therefore the system will be having infinitely many solutions. Right, I had discussion about all these things, so I'm just getting through it quickly. You know, that's if this is a system of equation, that's the corresponding augmented matrix. You know that, which we denote by A sub B or A B matrix. This is the system of equation. That will be what? This will be augmented matrix. You know, there are three row operations. In this case, we are calling them algebraic operations, but later on we convert them into row operations. So you can multiply an equation by a non-zero constant. You know that. You can interchange any two rows or columns depending upon the nature of whether you are going for row operations or column operations. So you can interchange any two rows if you are doing row operations, and or you can interchange any two columns if you are doing column operations. And you can add a multiple of one row to another row. I hope you know all these things, right? I'm presuming that you know this thing. Anyway, if you don't know, these are the row operations. You see, you can multiply a row through by a non-zero constant. You can interchange any two rows, and you can add a multiple of one row to another one. So these three are known as elementary row operations. Okay, these are known as elementary row operations. When you apply a row operation on a matrix, you get another new matrix. So the new matrix is basically equivalent to the old matrix, which I use a symbol that's tilde symbol. That was a symbol I used a bit earlier. We write R here, that means row equivalent. If you have used column operations, so that will be a column equivalent then. And you would write C here, right? For example, if you have a matrix like this one, 1, 2, 3, if you apply any of the row operations, these three operations, you may interchange any two rows or whatever. So we write that operation here. If you say interchange the rows 1 and 2, so it becomes -1, 1, and 2. That is 1, 2, and 3. Okay, so we applied operation R1, 2. So this matrix is row equivalent to this. So these two matrices are not same, you see. They are different, but they are equivalent. These two matrices are equivalent. We are using three terminologies in linear algebra usually. One is equal matrices. You know that if corresponding entries are same. Okay. The other one is equivalent, which we discussed earlier. Two matrices are said to be equivalent if they are obtained by applying any of the row operations. Either you apply one operation, you may apply two operations, you may apply three operations to get a new matrix. The new matrix is equivalent to the old matrix. And the third one is similar matrices. Right? We'll be discussing that similar matrices later on, which are different things. By word, they may mean almost same, but they are different things. So this is the system of equation. This is the corresponding augmented matrix. We apply operation on it, add -2 times the first row to the second, which we could write in this form as well. We could write in mathematical form. That is row number 2 minus 2 times row number 1. You can write that in this form as well. It's better to write in this form. Okay, and then if you convert this into corresponding equations, that will be this way. See, now x is gone, so there will be no x in second equation. And then we apply again another operation, add -3 times the first row to the third row. That is, we do row number 3 minus 3 times row number 1. That's the operation we can do. And then the corresponding equations are this one. If you want to convert the equation into it back. And then the next operation is what? We are basically making this quantity 1 If we are converting this into echelon form, so we do what? We simply take 1 by 2 times row number 2. The corresponding equation are these ones. And further, in fact, what we are doing, we are converting into echelon form, obviously. So up to here, the first step, we converted that into echelon form. That's the echelon form. Then we want to make this one 1, so multiplying by minus 2 to get this one. Then we make these two, this one 0 and this one 0 as well. We have this in reduced echelon form, which directly give you the values of x, y, and z. This is the value of x, this is the value of y, and this is the value of z. And this method is then known as, it is a Gauss-Jordan method. It is done here and it is explained later on. But you know it, obviously. Let me update the attendance now. Do you understand what I'm doing? You can check your name. Abdur Rahman,
Yes, sir.
Behram Khan,
Yes, sir.
Hadi Hussain, Hadi, इसकी जगह कोई और साइन हुआ है?
पता नहीं सर.
हमजा हुसैन,
Yes, sir.
हसीब मंजूर, हसीब, हिबा,
सर मैं प्रेजेंट हूँ.
हिबा, लैला,
Yes, sir.
मोहम्मद अरमगान,
Yes, sir.
उसामा नईम,
Yes, sir.
वाजिद अली खान.
Yes, sir. Present, sir.
ठीक है. ये हादी का पूछ लें, नहीं तो उसको फिर मैं यहाँ से रिमूव करता हूँ क्लास से.
मैं मैसेज करता हूँ सर उसे.
सर खाली हुसैन ने मैसेज किया है कि मेरा माइक खराब है. अभी भी हैंड उठाया.
और ये भी रादिया अभी आई है. जी राधिया, क्या ये राडिया है, राधिया है?
हाँ दिया सर.
तो वो
Yes,
भी आ
sir.
गई हैं क्लास में।
No, sir.
ये जी,
सर पहले आई थी, डिस्कनेक्ट हो गया था।
आप तो प्रेजेंट नहीं है मेरे पास क्लास में। अभी आ गई हैं आप क्लास में, देखें 0 सेकंड हो गया आपको, 1 सेकंड हो गया अभी।
नहीं सर, डिस्कनेक्ट हो गया था।
ओके, एनी क्वेश्चन?
नो सर, कोई क्वेश्चन नहीं।
Do you follow what I'm explaining? जी, यार थोड़ा सा रिस्पॉन्ड तो करें ना। जो
यस
मैं
सर।
जो मैं एक्सप्लेन कर रहा हूँ सबको समझ आ रहा है?
Yes, sir.
यस सर।
यस सर।
ओके, so let's move further. Do these questions in book 1, 7, 9, 10, 11, 12, 14. Okay. I hope you have downloaded the book. Okay. So next we talk about Gauss elimination. I hope everybody knows that, so I'm getting through it quickly. I'll explain that as well. How do we do that? Okay. So before going into Gauss elimination, we first discuss echelon form. What is echelon form? There are usually three conditions for echelon form. That is what, if you have a zero row, that must be at the bottom, and non-zero entry, which is known as pivot of every row, that should lie to the right of pivot of previous row. There are two conditions, sorry for it. If there if there is any zero row, if any, that should be at the bottom. Keeping in mind, if there is any, if there is no zero row, you don't need to check this one. Sometimes student makes a mistake, they say there is no zero row, so it is not an echelon form. It is not necessary for echelon form to have zero row in it. Okay, but if it is in it, then it must be at the bottom. And non-zero entry of every row, that should lie to the non-zero of previous row. Non-zero entry of every row is usually known as pivot. P-I-O-V-T. P-I-V-O-T. Okay. Whereas for a reduced echelon form, it must be in echelon form, right? And all leading zeros, that must be 1. Leading non-zeros should be 1. That's pivot must be 1. And any column containing pivot should not contain any non-zero entry, right? If we combine all together, we say a matrix will be in a reduced echelon form if any zero row, that will be at the bottom. If there is any zero row, that must be at the bottom. right? All pivots should be 1. All pivots, that's non-zero entry in each row, that must be 1. Okay. And third one, pivot of every row should lie to the right of pivot of previous row. And the fourth one is a column containing pivot should not contain any non-zero entry, right? If a column contains pivot, there will be no non-zero entry other than that pivot. If a matrix satisfies these 4 conditions, it will be in a reduced echelon form. These are the examples. These matrices are in echelon, reduced echelon form, because there is no zero row. Okay, we don't need to check it. Pivots are 1. This is the pivot, this is the pivot, this is the pivot. They are 1. Okay, and every pivot is lying to the right of previous pivot. You see, this pivot lies to the right, this is lying to the right. And a column containing pivot, this is the column which contains pivot. There is no non-zero entry. Same thing here, same thing here. So this is in reduced echelon form. The same thing here. Again here as well, we are having 2 zero rows which are at the bottom. This is the pivot which is 1. This is the pivot which is 1. Right. This pivot lies to the right of this pivot. So third condition satisfied. This is the column containing pivot. There is no non-zero entry other than pivot. This is the column containing pivot. There is no non-zero value in this column as well. We don't care about these two, because these two don't contain a pivot. The same thing, this one. There are 2 zeros and both are at the bottom. So this is also, null matrices are also in reduced echelon forms. Okay. Whereas these matrices are in echelon form, but they are not in reduced echelon form. The reason is what? There is no zero row, so it doesn't matter. These are the pivots are lying to the right. Okay. Whereas you see, pivots are 1 as well. So 3 conditions are satisfied. Now you see, this column contains pivot. This is the pivot, if you see, and these two are not 0. Same, this one is pivot, but these two are not 0. So this is not in, this is in echelon form, but it is not in reduced echelon form. Same thing, this one as well, you see, and this one as well. Right, so these matrices are in echelon form, these are in reduced echelon form.
सर ये दोबारा बताओ.
ये क्या दोबारा बताऊं?
सर एक्लॉन और रिड्यूस एक्लॉन.
या
सर इसकी समझ नहीं आए.
सी मैंने किताब बताया था फर्स्ट. अगर आप इसको दोबारा मैं लिख लूं, if there are 0 rows, must be at the bottom. If you are having 1 0 row, that will be the last one. If you are having 2, that will be the last 2. They will be the last 2, and so on. Then pivot of each row. Pivot is what? First non-zero entry of each row. The pivot must lie to the right. Okay, that's the these two conditions are for echelon form. And if a matrix further consider or satisfy these conditions as well, so it become reduced then. Pivots should be 1. And the fourth one is columns containing pivot should not contain any other non-zero entry. Okay, then it becomes a reduced echelon form. Satisfying the first two only, that is echelon, whereas the next two will basically convert that echelon into reduced echelon. So if you look into this matrix, or maybe this one only, we are having 2 0 rows and they are at the bottom.
Yes,
Okay,
sir.
this is the first pivot, this is the second pivot, which is obviously the second pivot is lying to the right of the first one, so it is in echelon form. Now for reduced echelon form, you see the pivots are 1, this pivot is 1, and this pivot is also 1. The third condition is also satisfied. And then a column which contains pivot, this is a column which contains pivot. Do you see any other non-zero entry? This is 0, this is 0, this is 0.
No, sir.
And the next column is this one which contains pivot. There is no other non-zero row, non-zero entry. Right? This is in a reduced echelon form. Whereas in this case, you see, there is no zero row. So forget about the first condition. This is the pivot, the first pivot or the pivot of first row. This is the pivot and this is the pivot. So all the pivots lying to the right of it. So these are in echelon form, but they are not reduced because, yeah, the third condition is satisfied as well because pivots are 1. But if you see this column which contains pivot, this entry is not 0. So condition number 3 is not satisfied. So this is in echelon form but not in reduced echelon form.
Yes, sir. समझ रहा.
This is a pivot, this is a pivot, and we are having 1 0 row which is at the bottom. Pivots are to the right, so they are in echelon form. Even though third condition satisfied, the pivots are 1 as well. For echelon, it is not necessary. But if you see the second column which contains pivot,
Yes, sir. वो 0 1 है उसमें.
yeah, there is 1, so it is not satisfying. That's the fourth condition. Therefore, this is in echelon form, but not in reduced echelon form. The same thing for this one as well, right? You can check it yourself. You may take a screenshot of it. You can take it. It's up to you.
Yes, sir. हो गया.
So these are some further examples. Okay. These are in echelon form. The first part, the steric basically means they may or may not be 0. The 0 means they are 0, and the 1s means they should be 1. So, yeah. The same thing, these matrices are in reduced echelon form. These are in echelon form, whereas these are in reduced echelon form. Okay. So, as I said earlier, in this case, there are 4 equations and 4 variables. So once you convert a system into reduced echelon form or echelon form, and number of equations are same as number of variables, in that case the system will be having unique solution. Otherwise you can go for that rule as well I explained earlier. You see, this is non-zero, so the system will be having unique solution, and there are you see number of equations are same. Another example, I explained this thing all. You see, in this case you see the last row, this is the augmented matrix, keeping in mind. So this one is 0, this is not 0, no solution, many solutions, again many solution. Okay. Should I explain it again or it's okay now? These are explained already. Explained as well. Yeah. Anyone want to ask something or some what? Okay, so if a linear system has many solutions, then a set of parametric equations from which all solutions can be obtained by assigning numerical values to the parameters is called a general solution. You must practice. You must practice converting a matrix into echelon form or reduced echelon form, because we'll be doing that again and again. Okay. So if you have this matrix and want to convert that into reduced echelon form, you should do that yourself, because if I do it, it is not obviously of any worth, because I'll be practicing it. You may not practice it yourself. You should do it yourself, right? There are many ways of doing that, so it's up to you. You see, if you want to convert that into echelon form, what do? We need to make this one non-zero. Interchanging these two rows, that's the first operation we apply. We get this one, 2, 4, minus 10, 6, 12, 28 here. And then we make this one 1. Usually make the pivot 1 even though for echelon form as well, because making it 1 and then applying those operations, they might be easy. Okay. So this is 2 now, and then you can divide it by 2 to get 1, 2, minus 5, 3, 4, and 14. And then we can, this is already 0, we can make this one 0 as well. Or you can make them 0 by directly subtracting it from there. You see, row number 3 minus row number 1. So 2 minus 2 is 0, 4 minus 4 is 0, minus 5 plus 10, 6 minus 6 is 0, minus 5 minus 12, minus 1 minus 28. Right? So you see this one. Now next time you need to make this one 0. Okay. And that can be done by making this one 1 first, dividing by minus 2, and then subtracting it 5 times from it to get this 0. So this is the this is the echelon form now. To convert into reduced echelon form, what do? We simply making this one 0 and these two 0 as well. Okay, which is done. So that's all together in a reduced echelon form. Oh, it's not still reduced echelon form because we need to make these two 0 as well. So at the end, this is the reduced echelon form. Okay, you should practice it yourself, right? If you don't practice, I will be making a lot of mistakes. Okay, so we are having basically two types of methods. One is Gauss elimination and the other one is Gauss-Jordan. In Gauss elimination, what do? We convert augmented matrix into echelon form, and then by using backward substitution to get solution of the system of equation. Whereas in case of Gauss-Jordan, we convert the given augmented matrix in reduced echelon form. Okay, so let's do this example. If this is the system of equation, okay, x1 plus 3x2 minus 2x3 plus 2x5 is equal to 0, and so on. There are 4 equations with 6 variables. So first we take augmented matrix. That's the coefficient 1, 3, minus 2, x4 is 0, x5 is 2, x6 is 0, and the right side is 0. 2, 6, minus 5, minus 2, 4, minus 3, and so on. Okay, now you would make these two 0 first. So row number 2 minus 2 times row number 1, row number 4 minus 2 times row number 1. So these two 0. Next time we'll be making these two 0. Subtracting again. You can make this one as well. So this rows become 0. So we'll interchange these together because we need to have a last row as 0. So we get this one. Okay. So that's the reduced echelon form now. This is 0. The last equation will give you what? This one, x6 is equal to 1 by 3. And then we have x2 plus 2x4 is equal to 0. x1 plus 3x2 plus 4x4 plus 2x5 is equal to 0. We convert this into again equations. Now we are having 3 equations and there are 6 variables. It means there will be 3 free variables. Okay. From this equation, we can have x4 as a free variable. To introduce x4, x4 may be, you can take r. From this equation, we are having 2 more free variables, x2 and x5. So 1 free variable from here and 2 free variables from here. So we get altogether 3 free variables. Because number of equations are 3 and number of variables are 6. So there will be 6 minus 3, that is equal to 3 free variables. So how do we determine them? So see, the second equation is what? X3 plus 2x4 is equal to 0. So we can have one free variable from here. You can take either one. You can take x3 or x4, right? So in this case, we take x4 is equal to r. So x3 will be minus 2r. And then we move toward first equation. So first equation is saying x1 plus 3x2 plus 4x4 plus 2x5 is equal to 0. Okay. In this case, we know x4 is already taken as r, and then we don't know x2 and we don't know x5. Again, they are free variables, so we can introduce some new free variables. We may take x2 as s and x5 as t. x4 is already taken, you don't need to take it again, and that will give you x1 then. So we have the following solution: x1 is minus 3r minus 4s minus 2t, x2 is r, x3 is minus 2s, x4 is s, x5 is t, and x6 is 1 by 3. If you have any question, you can ask. Is it clear? Okay, let me update that. Okay, do you have any question?
No, sir.
No, sir.
Should we move further? Yeah, that's it.
सर इतना
It's in काफी है, sir.
इतना काफी है.
यस सर
अगर ये मैं 1 घंटा पहले कहता तब इतना ही काफी होता ना. Okay, next lecture we'll be talking about homogeneous system of equations. Okay, इसकी discussion हम करेंगे and so on. You may do exercise 1.2. Okay, just to check it whether solve only the non-homogeneous system in that.